Assalamualaikum, you are from group 59. We will be presenting optimum dosage of coagulants for jar test. We have 4 team members, myself, Nurul Farhani binti Uthman, second is Amir Hamzah, third is Muhammad Nazmi Ashraf, and fourth is Azni Linus. Introduction. The use of seawater as a raw material for industrial process water is now needed along with the limited availability of groundwater, especially for factories located close to residential areas. But the use of seawater is certainly not as simple as the use of groundwater because seawater has a high salt content and metal content that will damage the equipment if not processed first. In this study, the method used in seawater treatment is the method of coagulant and flocculation, with consideration of equipment that is simpler and can be done anywhere. Coagulation and flocculation are the process of collecting particles of the clouds that cannot be precipitated by gravity into larger particles that can be precipitated and separated from the fluid. In the method of coagulation and flocculation, it is necessary to use chemicals that function as coagulant and flocculant. Determination of appropriate dosage in the use of coagulant and flocculant is needed to use of chemicals and processing costs become efficiently. We are conducted jar test for this experiment. Jar test is a pilot scale laboratory test that simulates coagulation or flocculation with differing chemical doses. The purpose of the jar test is to estimate the minimum coagulant dose required to achieve certain water quality goals. Jar tests are conducted on a 4 or 6 place gang stirrer, which can be utilized to simulate mixing and settling condition in a clarifier. Next, we move to the objective.
For the objective, this experiment is to determine the optimum dose of coagulant for specific water. And for the theory, chemical coagulation and flocculation are important processes used prior to sedimentation to increase solid removal within water treatment plant. Much of the suspended matter in water colloidal in nature. Colloidal suspended particles cannot be removed by gravity sedimentation alone as they are negatively charged, and repulsion of particles from one another keeps them in solution.
So for this lab exercise, we got 2 samples, sample 1 and sample 2. Okay, so sample 1, we take it from a downstream water sample. And for a classification, I just put it here in this bottle, downstream water sample for sample 1, and for sample 2 is a upstream water sample. I take it from the upstream water sample and just pour it here for classification.
Assalamualaikum, my name is Amir Hamzah. Okay, my part is a procedure of the jar test, and this is a step. Firstly, we bring one water sample from the river, and we bring to laboratory for the experiment. And for the first step is we take a water and put in the 1000 milliliter bottle for the, and we use a 6 beaker, and then preliminary fill the syringe with the different quantities of aluminum sulfate according to the task, which is for this task I use a 10, 20, 30, 40 and 50 milliliter, and we put in the different beaker. Before that, we label the beakers according to the aluminum sulfate dosage that is going to be added, and this is each beaker with the different dosage of the aluminum sulfate. And then we agitation speed at 40 rpm per minute. Let mixing for 15 minutes, and meanwhile we observe the settling velocity for 10 minutes, and after that we take the 25 milliliter of clear liquid, being careful not to agitate the sediment flock, and evaluate turbidity. And not to forget, before usage, it is obligatory to wash the turbidimeter container with distilled water and drain it well, being careful not to leave residual impurities. Fill the container with the sample which stability is to be measured. Finally, we evaluate the turbidity.